Okay, so dealing with data part 2. Nope. So where we left off last time, we were looking at this data set, which is relating radius to area for a shape. And we've graphed it out. I used Excel to graph it out, and this is what we were left with when we ran out of time. So the first thing you need to do when you graph something out like this is you need to identify what type of relationship we have. So this is a positive relationship where y is proportional to x raised to some power. You can tell this due to the exponential nature of the graph. Okay. Now, this could be 2, 3, 4, whatever. You'll still get this shape of graph. I think we know that we're going to expect that it's a squared relationship. But to prove it's true, we need to manipulate the data. So what we're going to do is we're going to take the data in this column and we're going to square it all. And we're going to see if that gives us a straight line graph. Okay, so I'm going to pop into Excel. I'm going to square each of these values and I'm going to regraph it. We'll see what it looks like. Okay, so if you're using Excel, I'll show you how to do this. So there's our data and there's the graph of the data. Okay, with and what I did here, just in case you're wondering, is I put a trend line in there just by double clicking, and you can pick which trend line fits your data best. So that's the line of best fit. Okay, so now we're going to take this data, and we said we were going to square these values. So the nice thing about a program like Excel is you can do this very quickly. So you put in a little formula, you go equals, and I want whatever's in this cell, so I'll just click it, A2, and we want to square A2. So just like on your calculator, you need to do a little hat and then the square button. And then if I hit enter, it'll give me that value but the square of it. And then I can just highlight the column below. I can hit Control D and that fills down. Okay. So now what that's done is it's taken whatever's in here, and you can see the formula it's doing. It's saying whatever's in A3 squared, filling it in here. Okay. So once you get used to using Excel, it can make your work a lot quicker. So we're going to highlight this, and we're going to go up to Insert, which you can't see. I'm going to do a scatter plot. Yeah, we're not messing with area. Okay, so now let's redo a chart title here. Okay, so this is actually not radius anymore, is it? This is the square of the radius. So let's just make sure we pop that in so we know. This is the squared values of radius. So what this is then is this is area versus radius squared. Okay. Now, why is that important? Well, you'll notice here that it's going to give us a nice straight line. And what we could do is we could just click on there, right click, go add trend line, and we put a linear trend line in, and you see that it hits all our data points. So this is now a linear relationship. Okay, I'm just going to add axes titles because we want to know what they are. So this is the square of radius, right? This is the square of the radius down here now, and over here is the area. We haven't touched area, right? And we've now made this graph a straight line graph. So now what we're going to do is we're going to figure out our y equals mx plus b values for this. All right. So what we need to know over on here is the slope, okay, and our b value, which in this case is 0. And then we can write a formula relating these two things. So let's pause for a second and go back to the other program. Okay, so for goodness sake. So we have our data here, right? And we've managed to manipulate it in such a way that it's going to produce a straight line graph. All right. This is what we're used to dealing with. All right. So the format of this graph then is going to be y is equal to mx plus b. It's a straight line graph. However, remember, the x in this case is squared, isn't it? So when we go back up to our original, you're going to end up with a squared value in here. All right, so that's where that squared value comes from. It's because we've squared our x value in order to straighten the line. Okay, so now we got to figure out, well, what's our value for m? So to solve for m, we go our change in y, our rise, divided by our change in run. Well, we could get these values right off of here. Okay, if you didn't have perfect data, like if your scatter plot was a line of best fit, say, say your points were like all over, well, you can't pull directly from your chart. You'd actually have to go and like look at data points that lie on here and import them. Because of the fact that all of ours are on the line, because it's sort of like artificial data, we could take them right from here, right? So let's go delta y. So we can go 172 subtract 1.1 over our run, which is 54.76 minus 0.36. We'll just get our calculators out and do some math. All right, so here's our slope, 3.1415, and let's actually rewrite our value now here, or our formula here, and see what it is. So our formula describes this data. Well, y in this case is area, so we can actually write it down as area is equal to m, which is 3.1415 blank blank, okay, times radius, in this case radius is squared, plus 0. Well, what we've done here is we've pulled the formula for a circle out of raw data, okay? So the area of a circle is pi r squared.